Today we will study about the location of tetrahedral voids and octahedral voids in cubic closed packed arrangement of face-centered cubic unit cell. Now here, this red ball represents the first layer, yellow ball represents the second layer, blue ball represents the third layer, and again the fourth red ball represents the fourth layer. This is A layer, this one is B layer, and this one is C layer. So here the type of packing is A, B, C, and then A, B, C. When these spheres are packed in ABC type of packing, the unit cell formed will be of type face-centered cubic unit cell. Let us have the view. This unit cell is face-centered cubic unit cell, where the atoms are placed at the corner of the unit cell, as well as one atom will be placed at the face-centered position of each phases, and such type of unit cell is known as FCC. Now let us consider the position. Let us locate the position of tetrahedral and octahedral voids created during the formation of FCC. Now, unit cell formed in this type of packing is FCC. Now, here is the example of face-centered cubic unit cell, where red ball represents the sphere which are packed in ABC type of packing. So red ball occupies all the corner of the unit cell as well as at the face centered position. Let us have the view. This red ball is present at the corners of the unit cell as well as at the center of the each phases. Now yellow ball represents the position of the octahedral voids. This yellow ball represents the position of octahedral void created as a result of ABC type of packing. These octahedral voids are present at the adjacent position at all the centers of the edges, as well as one extra octahedral void is created at the center of the unit cell. Let us have the view. Now, blue ball represents the position of the tetrahedral void. This tetrahedral void is formed on the longest diagonal, that is the body diagonals. Two tetrahedral voids are located at the body on each body diagonals. So there are total 4 body diagonals in a face-centered cubic unit cell, and each diagonal contains 2 tetrahedral voids located at 1/4 distance from the corner. This blue ball represents the tetrahedral void. Location of the tetrahedral void. It is located at 1/4 distance from each corner, and since the cubic unit cell contains 4 body diagonals and each contains 2 tetrahedral voids, so total number of tetrahedral voids created or generated in this cubic unit cell is 8. Let us count from the top. 1, 2, 3, 4. These 4 tetrahedral voids. This is located from 1/4 distance from this corner. This one is from this corner. This tetrahedral void is located from this corner, and another one is this one. 4 from these 4 corners on the top and 4 at the bottom. 1, 2, 3 and 4. So the total number of tetrahedral void will be equal to 8 two tetrahedral voids present on each body diagonals, and there are total 4 body diagonals. Hence the total number of tetrahedral voids formed in this unit cell is equal to 8. Now let us count the number of tetrahedral voids per unit cell in this cubic unit cell. The octahedral voids are placed at the edge center position, and edge is common between 4 unit cell. So the total number of edge centered atom will be 12 octahedral void that are present at the edge center position are 12, and the edge is common between 4 unit cell, and therefore the contribution from the edge center position is equal to 12 multiplied by 1 by 3, and that comes out to be 1 by 4, that comes out to be 3. And one octahedral void is present in the center of this unit cell, and it is isolated to this particular unit cell only. So the number of octahedral voids per unit cell will be equal to 12 multiplied by 1 by 4, that is the contribution from the edge center position, and that will be equal to 3, and 1 contributed from the body centered position because it is isolated to this particular unit cell only. So the total number of octahedral void per unit cell will be equal to 3 plus 1, that comes out to be 4. Now let us count the number of tetrahedral void in this unit cell. Since the tetrahedral voids are located inside the unit cell, they are placed on the body diagonal at 1/4 distance from each corner. Therefore they will be isolated to this particular unit cell only. So there are total 8 tetrahedral void, these blue balls, present inside the unit cell, and hence the number of tetrahedral void per unit cell will be equal to 8 because they are isolated to this particular unit cell only. Now let us count the number of spheres packed per unit cell. The position of spheres which are packed in CCP arrangement or FCC unit cell is equal to, they are placed at the corners of the unit cell as well as the face centered position, and the number of corners are 8, and corners are common between 8 unit cell. Therefore the contribution from the corner will be equal to 8 multiplied by 1 by 8, that comes out to be 1, and there are total 6 phases. Each phase contain 1 face centered position, and the total number of face centered atom will be, or the sphere placed at face centered position will be 6, and face centered is, contribution of face centered sphere will be just half. So 6 multiplied by 1 by 2 will give you 3. So the total number of sphere packed in FCC is equal to 8 multiplied by 1 by 8. Number of sphere packed per unit cell will be equal to 8 multiplied by 1 by 8, that comes out to be 1, and 6 spheres present at the face center position multiplied by 1 by 2 will give you 3. The contribution from the face centered position will be 3, and contribution from the corner will be 1. So the total number of sphere packed per unit cell will be 4. The number of sphere packed per unit cell will be equal to 4. Now let us calculate the number of octahedral void. The number of octahedral void per unit cell will be the contribution from the edge centered position. There are 12 edge centered position at which the octahedral voids are located. So 12, and edge is common between 4 unit cell. So 12 multiplied by 1 by 4 will give you 3. The contribution from the edge center is 3, and 1 octahedral void is created at body centered position. So the total number of octahedral voids created per unit cell will be 3 plus 1, that comes out to be 4. Now let us calculate the tetrahedral voids per unit cell. Since tetrahedral voids are located on the body diagonal and body diagonal lies inside the unit cell and they are isolated to a particular unit cell only, so all the 8 tetrahedral voids will be placed inside the unit cell and they are isolated to this unit cell only, and hence there are total 8 tetrahedral voids placed at 1/4 distance from each corner on the body diagonal and they are isolated to this unit cell only. So the total number of tetrahedral voids per unit cell will be equal to 8. Now the number of sphere packed, that is n is equal to 4, number of octahedral void formed or generated as a result of packing of 4 sphere per unit cell will be equal to 4, and the number of tetrahedral voids generated by the packing of 4 spheres is equal to 2 multiplied by 4, that is 2 multiplied by n, and that is nothing but 8. It means if n number of spheres are packed together, the number of octahedral void formed will be equal to n, and the number of tetrahedral void generated will be equal to twice of n. Here the number of spheres packed per unit cell is 4, number of octahedral voids formed per unit cell is equal to 4, and number of tetrahedral void generated per unit cell is equal to 8. Thank you.